so excited because, one, that's the first time I've had a high five before the talk started, and also, this is my first presentation in front of a dog, so I am really excited about it. There's a service dog here. Sorry to call you out on that. I'm just so excited. So.
She's looking forward to it.
Yeah, this is good. This is a very paw-friendly event. So, all right, thank you all for coming. I'm excited to see everyone. So I was going to tell you a little bit about myself and the things I've done, but I was like, that's probably boring. I was going to tell you about that I went to a boot camp, and I also teach middle-aged school girls robotics, but I was like, that's probably boring. So here's what you probably care about. I really prefer tabs over spaces. Yeah. I know, some people, I'm sorry if I'm offending anyone here. This is my favorite CSS, and Sandy Metz is my dev hero. I also just want to get this out there. I really like animated GIFs, so just prepare yourselves. Okay, this is where I work. I work for a company called Lean Dog, and it's in Cleveland, and that is our office. It's a boat. It's actually half a boat. It's actually older than the Titanic, because the Titanic was constructed in 1909, and that was built in 1894. So if you're ever in Cleveland, stop by. So you're probably here because you're wondering, what do rock climbing and coding have to do with one another? But first, let's thank our conference organizers, because it takes a lot of work. So when I went to boot camp, our first day, our first task was to make an account in GitHub and then fork a repo. Sounds probably very easy for experienced folks, but it was pretty horrifying for me. And so, I got through it, but I continually, through my coding practice, ended up in a very, sort of that same spot, right? And what is that spot? That spot is something like this, where I'm like, no, I can get in. I can read, but I can't do it for some reason. So what I realized is as I continued coding, I would, discover a problem, look down into it, and then start investigating, start doing things, and then pretty soon I'd be falling. Pretty soon I can't tell up from down. Then I land somewhere and I have no idea where I am. I'm around all these characters that I don't understand. And then more importantly, I have no idea which direction to go, right? And this happened continually. So it wasn't just the first day of boot camp, but I ended up like this a lot. So at some point, I was sort of wait a second. I should probably do an assessment of what's going on and how do I get better? So I'm a better rock climber than I am a coder, which isn't that hard to do. But I realized that a lot of the best practices that I was doing in climbing were actually the ones I was trying to do in coding and just failing miserably at them. And so that was the inspiration for this talk. So there are 7 sections to this talk. It's going to be sort of fast, but the slides are on SlideShare, and I'll go through that at the end. But here are the 7 topics. So here we go. All right, the first one is breaking down the problem. All right, this can be a pretty scary place to be, right? You've got a blank screen. It seems pretty exciting, but it's also terrifying, right? Because every line of code that you write, you're accountable for, and it could be totally wrong. But also, this could be a scary place to be too, right? So you're committed, and you're entangled, and if you fall, then that's not good, but if you go up, the stakes get even higher. So I figured out that there's 2 approaches. There's jumping in, and there's planning. So I've worked with more people than not that once they read the requirement, it's off to the races. How many of you do this? Yeah, and that's okay. No judgment, no judgment. Because I don't think it's really your fault. You probably have more experience than me, but also, right, we have this best practice, right, where we're hands-on keyboard means getting stuff done. And, putting Dilbert jokes aside, we actually have other best practices, like coding best practices, right, about things like failing fast and addressing uncertainty up front and gaining experience. So we're told, okay, let's just try it. Let's just jump in. But what I've realized is those best practices are exercised for best exercised by those who are confident. And so what do I mean by that? I mean that the confident are generally those that have experience and skills. And it comes from knowing. You know how to hypothesize and experiment effectively. Experienced folks and confident folks are used to failure and also used to meaningful failure, right? Like you're able to discern a good failure from a bad failure. Someone with less experience can't actually tell the difference. Understand the feedback that you get. You also know when to stop, I would say mostly. And you also understand succeeding by accident. And you can do all these things quickly. So for the confident, failure seems safe and practical. But if you're not confident, jumping in can feel pretty scary, right? So you're unsure and unaware of divergences. There's a lot of backtracking because you're not sure if you're getting the right feedback that you want. You're still figuring out your skills. There's an increased number of cycles that you're going through. And after a while, it starts to feel unsafe. Because being wrong a billion times is really tiring, right? So things are going to feel scary to someone that's new to coding, right? So if you're experienced climbing, like falling, like this guy is doing, you're like, oh yeah, I fall like that all the time. But if you're new to it, that can feel pretty terrifying. Yeah, there's a rope. It's cool. All right, so I'm going to talk about planning. And I'm going to use an example of Tower of Hanoi. Has anyone done this kata before, this exercise before? Okay, I'm not going to go through it, but at a high level, like you can look it up, it's online. But at a high level, basically, you want to move like all those disks to another peg. Okay, there's some rules. We're not, you don't need to know all that, but it's fun. So that can feel pretty overwhelming to someone that's new, even though it seems pretty simple, right? But it still can feel pretty overwhelming. This actually starts to help, right? Now I'm breaking it down to 7 steps. I sort of understand, oh, okay, here's how I get to the end state. And then what you can do is you can basically go from 0 to 1, right? So from 0 to 1, I only need to worry about 1 disk, really. I only need to worry about 2 pegs. I only need to worry about 1 movement. And I don't even really need to worry about rules yet. Right, and continuing on from 1 to 2, so I have 1 more disk now, I have 1 more peg, I have 1 more movement, and now I have a rule, right? I have a rule because these are different sized disks, and the larger disk could not go on top of the smaller disk. So I'm not going to go through the whole entire thing, but you get the idea that we've broken down the problem, and I only need to worry about what I need to at the stage that I'm at, right? And eventually, we get to something like this, and we feel like $1 million. So planning gives folks time to think and analyze before doing. We reduce cognitive load by focusing on one part of the problem at a time, and it promotes just enough pragmatism. And then the softer side of things is that means that I don't have to worry about everything. It reduces my stress level. I start to understand things because I can focus on one part of the problem, and again, facilitates focus, right? So I'm going to give an example. You guys, if you're like me, use something like this in high school. I think it's a compound microscope. So you'll notice there are three lenses. And so the lenses, let's just say, I can't remember the exact magnifications, but let's just say it's like 1x, 50x, and 100x, right? So, and so when you did this, you're probably like really excited because that looks really fun. And you got like an onion cell or a cheek cell. And so, right, like you get your cell, and then you put your iodine, you put your slide on it, and then you like put it underneath the clips, and then you're like, okay, I'm really excited. And so then your teacher says to you something like, okay, get your cell in view at 1x, right? Once you do that, then switch to 50. Once you get in view again, go to 100, right? And so if you were like me, you were like, if I'm going to 100, why would I stop at 50? Like, that's super dumb. Like, I'm going to 100. I don't even know why there is a 50x. And then, so, right, if you're like me, you did it, and then you ended up with something like this, which is like no cell in sight. And so I would say that there's a parallel in this for coding, right? When you plan out, you know where you're going, but you're taking an intermediary step to make sure you know what you're focusing on. So for our technical practices, here are some takeaways that you can do with just yourself or with others in terms of planning. My favorite is technical tasking. So you have your requirement, like literally break out that requirement into the things that you need to do to make it work, right? Sketching, if there's like UI, whiteboarding, if there's diagrams and data flow. It allows folks like me to think through the problem at the beginning, as opposed to having to think about it while I'm doing it, right? And so it allows people like me, the less experience, to gain confidence, right? So we're mimicking the confidence and the experience that we don't quite yet have by walking through the problem first. So in climbing, I actually see this a lot, and I see it from experienced climbers do this. You see these two people, so there's this person and that person, they have their arms up. They're not just walking around like zombies or anything. They are actually planning out how they're going to climb. And if you go to a climbing gym, or if you go outdoors and see people climbing, you will see them do this. You'll see them planning out their route. Because climbers know that thinking and analyzing while doing is hard. And the reason why it's hard is because gravity, #science, right? So climbers like to climb, that's no surprise, but they understand that their energy is finite. So they want to climb more. In order to do that, they want to be able to think through everything that they have to do before they actually start doing it so they can climb longer or harder problems. Thinking and analyzing before doing conserves energy. This is one of my favorite gyms. It's in Brooklyn, New York. It's called Brooklyn Boulders. And that's called the Cave. So I just want to mention, though, that active planning is greater than the actual plan. Right? And so don't get too hung up on the plan, right? The fact is, like, we've actually done the activity. If you're working with someone else, you're both on the same page about the direction you're going, because you want to be able to respond to change. So the act of responding to change is greater than following a plan, and following a plan is greater than no plan. So thinking through the problem feels safer, even when the plan doesn't work. That's not me, although that does happen to me. Right? So number 2 is keeping calm and coding on. Okay, so there's some really real failures with climbing. This is a Lake Erie shark. No, I'm just kidding. There are no sharks in Lake Erie. Yet, that's true, right. Who knows what's going to happen. But there are some failures with our projects, right? And I'm not going to go through all of this, but there's a report that's done every year. It's called the Standish Chaos Report, and they basically do an analysis globally about tech projects and how successful they are. You can look it up online. The main point here is that you'll notice year after year, our success rate globally is not great. So, you know, people are probably thinking about this. We're probably thinking about this. Our managers are probably thinking about this. Our customers are probably thinking about this. So failure is real. Or is it? So I want to talk a little bit about failure. What we believe about failure. So what we believe started when we were kids. We get rewarded for A+. And we usually get the test once. And so we're supposed to get this A+ on the first try, by the way. So we start to believe that failure is bad. And also, because we're kids, we don't take failure, that failed test or whatever, as an isolated incident. We actually start to internalize it and believe that failure means I'm dumb. Uh-oh. Failure. It's just feedback. Okay, great. Failure is perfection. No. So being smart equals perfection. That's essentially what we're taught as kids. We also believe being smart means winning, and usually that means against others. So there's this article, I'm not going to read it all to you, obviously just go to the New York Times, but this guy wrote about how he has 2 kids and they're toddlers, and it's like their evening routine, and you know they're going to bed, so one of the things that they do is brush their teeth, and his 4-year-old is like, oh, I'm going to win, and it's like brushing his teeth. So I don't know, you know, he talks about how he's like, I don't know where my 4-year-old got this, but this competitiveness is, like, we're raised with this competitiveness. I mean, who's going to have the best Halloween costume in a month, right? We also believe that others define smart, right? We even have memes about it. So people start to talk about, right, you hear this, oh, they're giving their 110%. They show initiative. They're going above and beyond. They're clever. They have 4.5 GPA, which I don't even understand because I thought it was a 4-point scale, but that's fine. That's just math, I guess. But it's to the point where we even talk about people that are trying are tryhards, right? So Emily just talked about in her keynote imposter syndrome. Right, so this is very much a thing, right? People who internalize, they're unable to internalize their accomplishments, and they have a fear of being exposed as a fraud. They question whether or not they know something, and even Fast Company. Okay, so Fast Company, not your psychology magazine, right? Earlier this year, talked about not only is there imposter syndrome, there's 5 types of imposter syndrome. Again, I'm not going to read this to you, but the point is, people are talking about it. It's a thing. So this is, and I want to talk about this for a minute. Does anyone recognize this painting? Okay, so it's called The Potato Eaters. Does anyone know who it is done by? Yeah, exactly, Van Gogh. Thanks. So yeah, Van Gogh. And he considers this to be his most successful painting, right? And so when he was doing it, basically he got some pretty harsh criticism and feedback from a friend of his. And it took him a while to think about it. And eventually he responded, and he said to his friend, you didn't have a right to criticize my work because I'm always doing what I can't do yet in order to learn how to do it. So even Van Gogh, that guy, talked about basically this pressure and judgment from others. So the good news, not only about Van Gogh, but the good news is that people are talking about what success really is, right? Like, we're living in a very good time. So people think it looks linear, but we're actually talking about what it really looks like. It's not linear. Not only that, people are talking about the value of failing. And further, people are actually talking about how they themselves have failed and persevered. So my point here is that we need to reframe the failure mindset, right? Failure is feedback, and failure is just a change agent. So 3 is Gemba. Has anyone heard of the word Gemba before? All right. It comes from lean manufacturing. So Gemba, it's Japanese, and it means the actual place. And so where it came from is essentially Toyota had a really good partnership with its suppliers. And the suppliers would even be in their factories. And so the cars would be moving down the line. And if something happened with the car, first thing would happen is the person that was working that station would look at it. If he couldn't figure it out, he would basically get the supplier to come down and literally look at the car and the part, and together they would try to figure out, hey, what's going on, before the car continued down the manufacturing line. And so what I mean by this is practice, right? Go to the place where things happen. More specifically right now, I mean practice failure and practice failing. So by this, I mean 2 things. 1, differentiate expected from unexpected failure. And 2 is get used to working through failure. So in climbing, we do this actually all the time. So if you go to a climbing gym, how many of you have actually been to a climbing gym? I know this is a very outdoorsy area. So, okay, yeah, cool. So if you've ever wanted to belay someone, which is like this person, you actually have to take a belay test, right, to make sure you can know how to catch people and how to belay properly. In order to do that, this person has to pretend to fall. You can actually just do that if you want to get comfortable. Practice falling, right? And even Climbing Magazine talks about how, essentially, if you're not falling, you're not climbing hard enough. So we can do this in technology too, right? So we can prime ourselves for failure. We can do TDD. How many of you do TDD? Test-driven development. Yeah, okay, cool. So I love the idea of, hey, I wrote a test and it's failing. I did it right? I failed and it's exactly what I wanted, right? And then you can make it green and then you can refactor, right? Refactor under green. You can even do, if you want to make it even more fun, you can do things like ping pong. So you have like, if you're working with someone writes the test, the other person has to make it pass, which is super fun. Or you can do mob programming, right? So you can have a few folks together and you can work through a problem together. Some other ways that you can prime for failure is push and roll back, right? That's actually one of the scariest things that I found, the whole command line. So just practice reverting or resetting, amending commits. Also practice investigating, right? Like do a git diff, do a git blame. Actually, maybe do a git praise, which is actually like a real thing, which is sort of exciting. My point here is that practice reversing expected failures. So 1, set yourself up for failure, okay? And 2, reverse the failure. Get used to saying in your brain, I failed, but I was right. So what we're doing right now is we are rewiring and reframing what we're taught at an early age. I failed, but I was right, as opposed to I failed and it was bad. So practicing with expected failure prepares you for unexpected failure, because you know how to handle the situation. So I'm just take a quick, this is a bit of what I do for my work, for my real work. So I want to talk a little bit about the spectrum of domain uncertainty. So we often talk about certainty in a couple ways. One is, do I know how to do the thing before I actually start doing it? The second is, when I'm doing it and something goes wrong, do I know how to respond to it, right? And so there's our spectrums. One is knowable to unknowable. So if we were all making bricks in here, I'd say that we would know basically how to make bricks pretty upfront, right? Like we know that the material is pretty much the same. We know the sizes are pretty much the same. And we know how to deal with that. We know when the weather's bad. We know how generally how to deal with that. But I would say what you all are doing is closer to the unknowable side of things. So you're inventing. So just remember that and give yourself a little bit of a break. So the other thing I mean is practice. For climbing, I literally mean go climb. Right? Practice different techniques. And so I want to talk a little bit for developers how we are expected to practice on production code, which I think is ironic that it's like the best practice is to practice on production code. So does anyone know who this guy is here with the nice blazer? Okay, his name is Corey Haynes. So he recognized this, and he talks about how in every other profession, people get to practice. So your favorite sports athlete, sorry, I don't know anything about sports, so yeah, your favorite sports athlete, they get to practice. Your favorite musicians, they get to practice. Almost every other profession gets to practice. We don't get to practice. Our practice is every day, and it's real life, right? Oh. Okay, so there is this event that he basically organized, and now people just like take it over for their own local communities. Maybe there's this happening around here. It's called Global Day of Code Retreat, and it's a day where practitioners get together, and it's language agnostic, and you go through. I think they do Conway's Game of Life, so that exercise, and you get to practice. You can try their languages. You can try TDD. You can try however you want. But also, practice. Like get a sandbox, right? So you can use CodePen, or there's a lot of other sandbox tools that you can use. Also, go to hackathons. And then I guess I wanted to mention this tool. It's called Exorcism, like EXE, right? Not EXO. That's a different thing. So exorcism.io is a site that basically they're katas. And you work through a kata, and then a kata is like an exercise, and then you submit, right? And so once you submit, then you can see other people's solutions, and it basically teaches you two things. I mean, aside from how to do that one problem. But the one thing it teaches you is how to read other people's code. Like reading code is super important, but we never really, I mean, when we do it normally, is like we don't have the same context as other people. It's usually like a year later, and like you've walked into this code base, and everyone else has written it, and you're like, okay, what, like you don't have any, there might be comments, but you don't have necessarily the historical knowledge. This allows you to read code, and you've just completed and submitted that same exact problem. So you actually have the context. So it's a good like little step up to learning how to read code better. The other thing it allows you to do is learn how to accept feedback and give feedback in, in a nice way, right? So you can comment on other people's code, you can try out their solutions, or you can recommend solutions. So number 4 is continuously improving, which is Kaizen in Lean. So I mean 3 things here. I mean mastery, measurement, and mentorship. So for mastery, I mean mixing and matching and experimenting. So solve problems differently. So try different programming paradigm, right? Try imperative or object-oriented. Try different approaches. Like if you're used to doing outside in, do inside out. And then try different tools. Learn another language, right? So, and then try, after you learn a language in depth, learn another and write it in your first language syntax. So try writing Ruby in a Java way. The second thing here is measurement. So what I mean throughput in the fields. Does anyone use Pomodoro techniques or have heard of it? Okay, yeah, cool. So time box how long you've worked, and just continually measure, see how you're doing, right? You can also modify. So when I was coding, I would try to get my team to do plankadores or wall sit-adoras. Yeah, I wasn't very popular with my team. But I got stronger, though. So you can also use like a Kanban, right, or like a story wall. Just see, even if it's your technical tasks, just start to measure, see how you're doing. Or do a retrospective, right? And you can see every once in a while just basically what you want to continue doing. So basically what's working, what's not working, etc. And every once in a while, take a step back and see how you're feeling. Like, are you feeling like this, or are you feeling like this? So the third thing is mentorship. Does anyone know who this guy is? So he's a quantum nuclear physicist, no big deal. He won the Nobel Peace Prize. But the reason why he's amazing is because he is so humble. He was a college professor as well, and he basically admitted that if I can't explain something to a freshman class, then I don't really understand it. That's pretty amazing, right? Because knowing how to teach others is much different than knowing how to do it yourself. You should listen to this YouTube sometime. It's really fun, this TED Talk, because physics is fun to imagine. So my point here, and something that he recognizes, is that there are gaps in experience, right? So people that are new don't know about the vocabulary. They don't know the mechanics. They don't know the syntax. They don't know the rules. They also don't have the mental models. They don't know the strategies. They don't know patterns. They don't know behavior. They don't understand what classes are, how to test. So they're very much like aerial, right? Like, oh yeah, fork. I think I know what this is for. It's totally for brushing my hair. So bridging the gaps, right? So one way is to find a common world. Something we learned in, I think, like high school English, use similes and metaphors. Find a way to relate to that person, right? Use visuals. Also build an understanding. So in improv, there's something called yes and. It's a technique. It's a technique where folks get together, and no matter what the person that's on stage with them says, everybody else has to build on it, right? Can you imagine if you went to a show, and if they were doing improv, and someone's like, oh, look, there's a, I don't even know, there's a lion, and everyone else is like, there's no lion. You'd be like, this is the most terrible show ever, right? You want to believe. So you're basically improving with others when you're pair programming, for instance, or teaching others. You're improving with them. So it helps. Also write pseudocode, right? So build an understanding. A couple other techniques is pay attention to nonverbals, right? So take breaks frequently. See how people that you're teaching are sitting. Are they sitting with their arms crossed? Are they frowning? Are they smiling? Are they laughing? Also do mutual involvement. So zone of proximal learning. It's also called shuhari. Main concept here is, I sort of want to time those and see if they happen like every 12 minutes or something, just to see. But yeah, so the main idea with zone of proximal learning is I do, you watch, I do, you help, you do, I help, you do, I watch, right? So the whole, it's like boiled down, teach a man to fish, right? Teach a person to fish. The other thing that I really loved when I was coding a lot more is attributing a single commit to multiple developers. If someone's new, they don't have a lot of experience, especially if they have imposter syndrome, wow, they feel, that was definitely less than 12 minutes. Okay, they feel like $1 million if they get to see, like in GitHub, their like little square get darker and darker green, right? It makes them want to continue doing it more, right? Building on that like positive experience. So the other thing I learned from climbing is that effective mentorship can mean different things to different people. So when I climb, and I'm climbing with people that are stronger climbers than me, I actually don't want to be told what to do. I want to figure it out, because I think it's like super fun that way. But some of my friends I've gone climbing with, and they're not very strong climbers, they want to be told, like every step of the way, okay, right hand, there's a hold right by, right by your right knee. So there's different people want different things, and so you have to figure out what that means. All right, so you're probably wondering, what does Star Wars have to do with this? Yeah. All right, always, yeah. So I'm going to get to that, and we're going to talk about follow your bliss. Does anyone know who this guy is? Joseph Campbell. Yeah, he's really awesome. There's a really great talk between Joseph Campbell and Bill Moyers on PBS. You guys should listen to it. It's about the power of myth, which is another one of his books. But essentially, Joseph Campbell, I believe he was an anthropologist. He wrote this book called The Hero's Journey. He really understood what it meant to, to be a hero, right? Where you're the center of the story, and basically what you have to go through in order to succeed. So what does Star Wars have to do with this? Well, when George Lucas was writing Star Wars, he was having a really hard time. And he was like, I got this guy, Luke Skywalker, there's lasers, I don't know. And he called up Joseph Campbell and was like, hey, can you help me figure it out? And so Joseph Campbell went to George Lucas's ranch, and then they figured out how to like make the story work. But Joseph Campbell also coined the phrase, follow your bliss. So heroes follow their bliss, right? Heroes, they follow the thing that they like to do, their passion, their purpose. And we actually have this too, in terms of, there's 2 books here, Now Discover Your Strengths and StrengthsFinder. Has anyone heard of these books before? Yeah, okay, cool. I really like these books because, to boil it down, essentially what these guys say is, normally in corporate America, you go to a yearly review, and you basically get told something like, hey, you're doing great, but there's 3 things that we'd like you to work on. And these authors of these books are basically like, well, that doesn't make any sense, because people are good at some things and not good at others. And given that we have a limited amount of time and energy, right, science, hashtag science, then we should actually not spend a ton of time on our weaknesses, because we're never going to be great at our weaknesses with that same finite amount of time and energy. So he said, yeah, we should mitigate. So these guys said, yeah, you should mitigate the impact of your weaknesses, but really you should spend most of your time doing the things that you're good at and that you like to do. You should follow your passion, because you're going to go farther than you would if you focused on your weaknesses. So figure out how you love to code, right? In climbing, it's very common to have your favorite problem that you're working on. I love having problems in climbing. I love like coming back the next day and it takes me like 3 times to figure out how to do something. It's really fun and rewarding. In coding, we can do this too, right? Find a passion project. So if your work project isn't that exciting to you, find a passion project, right? There's a lot of, nonprofits that would love a little bit of help. But there's still challenges, even when you find a passion project. So 6 is dealing with difficulty. So how long should I hang out between a rock and a code place? I also think this is like a ridiculous photo. And I also like that she's laughing in this photo. So sometimes you fall, but it's actually within reach, right? Like you can actually do this. And sometimes you just can't, like you can't even start the problem. So you have to figure it out, and you should just not let this happen to you, right? By the way, I know this has been around, but I am like mesmerized by this. I cannot get over it. I also think it's hilarious because it's, there's like this coder ethos of like brute force. This is like literally brute force, right? Okay, if you see this happen to someone, like today, stop them, save them from themselves. Okay, so, through this whole entire talk, I'm not saying find problems are so difficult, and I'm not saying find problems are so easy. And I'm not going to go through this, but I guess what I want to tell you is that there are psychology studies about this. My point here is find your sweet spot. You don't want it to be bored. You don't want it to be so hard that you're frustrated. So start to focus, right? Start thinking about your intellectual energy as a finite resource, right? There's that phrase, perfection is the enemy of done. A friend of mine, he likes to focus on BDD. Like he likes to use those practices, right? He likes to make sure he's thinking about who is going to use it and who's paying for it, because they may not care if you shave 10 milliseconds off a call. They just may not care about it. Time box your effort, right? So just spend like 2 hours doing something, because otherwise you could end up like me in Alice in Wonderland, where you're like, it's like 4 in the morning. You're like, how did this happen? How did I even get here? Where am I in my plan if you're using a plan? And even Ken Beck is like, make it work, make it right, then make it fast, right? So I don't know if it's actually allowed that I'm allowed to put this up here, but it's on the internet. So, yep, okay, yep. So there are some other techniques. So pair program, right? If you're running into issues, try to get some other people's opinions. Do mod programming like I talked before. Talk to a rubber ducky, right? That is amazing. There's been so many times where I've been like, hey, can you come here and help me? And then I explain the problem, and I'm like, oh, thanks. And they didn't say anything to me. There's also this book called Refactoring by Ken Beck and Martin Fowler that I really like, and we'll talk about that in a second. And then Sandy Metz even has these rules of thumbs that, again, we'll talk about in a second. So in this book, Refactoring, basically in chapter 3, it's almost like refactoring recipes. So if there's like issues with your code and you don't know what it is, they basically are like, they've listed out some common problems. You figure out which one it is. So let's say it's feature envy. You're like, okay, also these names are super fun, by the way. But feature envy, okay. And then you look, and in the book it talks about like what are the symptoms and how to fix it, which is really helpful when you don't have a lot of experience. You're like, I don't know what to do with this. So that makes me feel good that someone else thought about it and I can try out some things. Sandy Metz has these rules of thumb for new folks. So classes underneath 100 lines, methods underneath 5 lines, method calls with less than 4 parameters. And the reason why these feel good for a less experienced person is because we're like consistently dealing with doing no harm, but also like not wanting to look completely dumb in front of like you all, right? So these are rules of thumb that a new person can follow, and then they feel confident. They're like, oh, okay, like I'm not doing any problem, and Sandy Metz is pretty cool. So if I do what she says, like I'm going to be cool. So and just so you know, in a podcast, someone did challenge her on this, and she basically said you can break these rules if you can convince your pair that why you should break them. So I think that's a good way to figure out if you should break them. Okay, we are wrapping up. Number 7, Minneswan. Has anyone heard of this before? All right, sweet. Okay, cool, some others. So I don't know who this guy is. I suspect if you know Minneswan, yeah, okay. I also think that is a hilarious photo and really wonderful. Like, I don't know where this came from, but I think we should all do it today. All right. So this is guy, his name is Matt, and he was the inventor of Ruby. I also think that's hilarious that these two photos are like nothing to do with Ruby. Okay, so, and there is this phrase in the Ruby community, and so I'm a Rubyist, and I'm sorry, I hope you all don't leave. So Matt is nice, and so we are nice, right? So he has this reputation in the community about being such a nice guy, to the point where in the Ruby community, they're like, oh, Matt is nice, so we should be nice. He talks about the value of being nice. So community matters, right? And working through problems with other people is really fun. The other thing I really like about climbing in terms of being nice in community is it really makes literal the benefits of diversity. So different body types climb different ways. Like, in fact, literally our centers of gravity are in different places. And I can climb something differently than you would, and we can both succeed. Like, we both get to the top. And I just love that. And I think that we can really take that to our coding practice too, right? There doesn't have to be like my best way or your best way. It's like, oh, hey, it works. So has anyone heard of Project Aristotle before? All right, so there's this company, it's called Google. You might have heard of it. So Google, in a very Google way, was like, okay, I need to figure out like the most perfect high-performing team. And they're like, they had some hypotheses. Was it like number of experienced people to less experienced? Was it gender? Like, what was it, right? So they did studies. And so what they found out was basically this. As long as everyone in the room got a chance to talk, the team did well. But if only one person or a small group spoke, then the collective intelligence of the team declined. So basically what they figured out is the best teams totally do what we all learned in kindergarten, which is be nice to other people, be nice to others. There's a fancy adult term, it's called psychological safety, so you can look it up. But it's basically like you feel comfortable commenting or contributing without someone coming back and making you feel bad. But literally, be nice to others is what it means. Right? Be nice. Maybe everyone should high five each other. I'm not sure, afterward, whatever you want to do. So these are the things we covered. These are where my slides are. And I think I have time for questions. Yeah. Sorry? Yeah, I know, really tabs. I know, sorry. I like tabs. It's only one, okay. Energy, right? It's only one, I only have to do this one versus a lot of, okay. Yeah?
You said a couple times when you used to do coding, you kind of alluded to what you do now, but what do you do now?
Yeah, okay, so I'm an organization design coach. So what that means is I use like agile, lean, and systems thinking practices, and I go to companies and help them try to get better at what they want to be doing. So like identifying like wastes and then inefficiencies in the process, and then implementing like tools and techniques to try to do that. Yeah. Yeah.
My experience being a mentor to others is mainly help us and I let them help me the problem.
Yeah.
Explain how they're going about it. And I've even done that with others where I may be more senior, but I'm willing to learn from their failures as well.
Yeah. Yeah, I love that. Thank you for commenting on that. Like just like letting folks talk through their problems and like listening really helps. Because again, like maybe it even goes back to that rubber ducky thing where they don't even realize what they're doing until they actually take a step out of their brains, right? Because in order to speak, we have to actually like step outside of our brains a little bit, and then they sometimes even help themselves, right? Hi. So I guess like we're all different people, but my favorite one is essentially the approach. Like I love it in so many ways, but I would say like the approach. So I really view climbing as a super joyful thing. And I really feel like not being able to climb something is a great challenge. And I look at it like positively, but I see like others, they get like really frustrated by it. So I would like, for me, I think the biggest is recognizing like a super hard problem or a less hard problem, and it's just being able to view it in a view it without getting like frustrated. Does that make sense? Yeah. Thanks for the question. All right, anything else?